A little progress each day adds up to big results.
Hi everyone. In this video we'll go through types of functions and few problems related to functions.
You can refer Relations and Functions playlist for videos specific to this chapter or Class 12 Mathematics playlist which has all the videos specific to mathematics. You can join the Telegram group for notifications on videos and any other updates.
So we'll go through two types of functions, one and onto. One is also called as injective and onto is also called as surjective. Now what is a one function? So say you have two sets x and y, right? X has elements a, b, c, d, e. Say x has 5 elements and y, set y as 1, 2, 3, 4, 5, 6, 7, right? So every element of set x should have an image, right? That is, element a should be related to some distinct element in set y. Element b should be related to another element in set y. So if you see in this example, a is related to 2, you can write it as a and 2, and b is mapped to 1, c is mapped to 4, d is mapped to 3, and e is mapped to 5 in this example. So for every first element a, b, c, d, e, there is a distinct element in set y. So this is a one function. Suppose you have something like this where element a and element b both are mapped to 1 year, right? So a as the image, these are called images also, right? These are called as images and these are called as pre-images. These are called as images and these are called as pre-images. So a has an image which is 1, b also has an image which is 1. So same element 1 as is mapped to two elements in set x. So this is many to one because many elements, more than one element in set x is mapped to one element in set y. So a is mapped to 1 and b is mapped to 1. So this is called as many to one. In one you should have one element in x mapped to one element in y. So it should be distinct, that is, it should be different. A should be mapped to 2, b should be mapped to 1.
That is, no two elements in set x should have same image in set y.
If you have multiple elements in set A mapped to single element, then it becomes many to one. Now this is the difference between many to one and one to one. So what is the definition for 1 A function x to y is defined as 1 or injective if images of distinct elements of x are distinct. Images of distinct elements of x. So these are the elements of x. These are the elements of x. It should have distinct images. Images are elements to which it is mapped. A is mapped to 2. So 2 is the image of A. B is mapped to 1. So 1 is the image of B. C is mapped to 4. So 4 is the image of C. D is mapped to 3. So 3 is the image of D. So that is for every x1, x2 belonging to x, that is to prove that the function is 1, you will have to prove that x1 is equal to x2. If x1 is equal to x2, it will directly prove that the function is 1. Now in problems, mostly you'll have to check if the function is 1 or you'll have to prove that the function is 1. In such cases, you have to show that x1 is equal to x2. Now what is onto function? Onto function or surjective. So every element in set y should have a pre-image in set x, or rather every element in set y needs to be mapped to some element in set x, right? So every element here, so 1 should be mapped to some element in x, 2 should be mapped, 3 should be mapped, 4 should be mapped, 5 should be mapped. So all the elements in set y, if it is mapped to some element in set x, then it is called as onto function. So you look at this example. This is onto. 1 is mapped to A, 2 is mapped to C, 3 is mapped to B, 4 is mapped to D, and 5 is mapped to E. So every element here is mapped to some element in this set, right? So this is called as onto. Now, what is the definition of onto function? A function f from x to y is an onto function if every element of y is the image of some element of x. That is, every element of y is the image of some element in x. So for every y belonging to y, for every y belonging to the set y, now in a problem, if you have to prove that it's an onto function, then you have to prove that f of x is equal to y. If you prove that f of x is equal to y, then you can say that it is an onto function. We'll look at examples for these functions. Now, what is a bijective? Bijective function is a function if the function is both 1, 1 and onto. If the function is 1, 1 and onto, then it is a bijective function. So this one is an example. So why is this 1, 1? Because every element A, B, C, D, E has a distinct image. A as 1, B as 3, C as 2, D as 4, E as 5. So there are different images to each of these elements in X. It's not repeated. So that's why this is 1, 1. Why it's onto? Because all the elements in set Y are mapped to some element in set X. Now if you look at this particular example, this is 1, 1 because A, B, C, D is having a mapping or is having an image. It's having an image in set Y which is distinct. A as 1, B as 3, C as 2, D as 4. So this is 1, 1. But this is not onto. This is not onto because 5 is not mapped to any element in set X. This is not mapped. This is not the image of any element in X. This is not an image of any element in set X. Therefore, this is not onto. A few things that we'll have to remember. What is a domain? Domain is all the elements in the set X is called as domain. So domain is A, B, C, D, E. So all these elements A, B, C, D, E is called as domain. Now what is range? Range is all the images, right? All the images or all the elements that are the images for the elements in set X is the range, right? In this case, 1, 2, 3, 4, 5. These elements are mapped to A, B, C, D elements in X, right? So these elements that are mapped is called as range. These elements 1, 2, 3, 4, 5 which are mapped is called as range. What is codomain? Codomain is this entire set Y. This entire set Y is called as codomain. So here codomain is 1, 2, 3, 4, 5, 6, 7. So this is codomain. And what is range? 1, 2, 3, 4, 5. Range is 1, 2, 3, 4, 5. This is range. So now you see the difference between range and codomain. Codomain is the entire set Y and range is only those elements in set Y which are mapped to elements in set X. Now let's look at the first problem. Show that the function from real number to real number defined by f of x is equal to 1 by x is 1, 1 and onto, where r star is the set of all non-zero real numbers. So here the function is 1 by x. That means the element in this particular set is mapped to elements in this particular set through this particular function 1 by x. So if x is equal to 1, then f of x is equal to 1 by x, which is 1 by 1 because x is 1, which is 1. So if x is equal to 1, then f of x is equal to 1. That is, so it will be mapped to this particular element. Now if x is equal to 2, then f of x will be 1 by x, which is 1 by 2, which is 0.5. That means this element 2 is mapped to 0.5. Now if x is equal to 3, then f of x is equal to 1 by x, which is 1 by 3, which is 0.33. So 3 assume that I have 3 here. So 3 would be mapped to 0.33. So this function tells you as to how to map the elements in this particular set to elements in this particular set. Both of these sets are real numbers. Now what are real numbers? Real numbers is nothing but it has all positive numbers, negative numbers, decimals, fractions. All of these are real numbers, right? It has positive numbers, negative numbers, decimals, fractions, half, 1/3, all of that forms real numbers. Now we will have to prove that this particular function, which is nothing but 1 by x, is 1, 1 and 1, 2. We'll have to prove that.
So let's take first one, 1, 1. So how do you prove this? You'll have to say you'll have to start like this. F of x1 is equal to f of x2. Now, what is f of x1? It will be 1 by x1, right? Because function is nothing but 1 by x, right? So I'll take x1 and x2 as two elements belonging to set x, right? We're just assuming that x1 and x2 belong to real number, right? The first set. So f of x1 is 1 by x1 and f of x2 is 1 by x2. Now let me take reciprocal. If I take reciprocal on both the sides, what will happen? It will be x1 is equal to x2, right? Now if anytime you get x1 is equal to x2, you also have to check if this belongs to real number, right? So since x1 is equal to x2, we can call this function as 1, 1. So you can say since x1 is equal to x2, function is 1 to 1. Now we'll prove onto. How do you prove onto? You'll have to first write the function. Function is 1 by x. We'll have to assume that y is equal to f of x. Y is equal to f of x. So what will happen? It will become y is equal to 1 by x. What is f of x? F of x is 1 by x. So y is equal to 1 by x. Now I'll move x this side. So what do I get? I'll get x and I'll shift y this side. So I'll get x is equal to 1 by y, right? So I'll get x is equal to 1 by y. Now what I'll do, if x is equal to 1 by y, what will f of x be? What is f of x? 1 by x, right? It's 1 by x. But what do we have in place of x? What is x equal to? 1 by y. So instead of x, I'll put 1 by y. Because x is equal to 1 by y here. Because x is equal to 1 by y, so I'll put 1 by y here. What is this? 1 by y is nothing but, I'll take reciprocal, I'll shift this on top. When I shift this on top, it will become reciprocal. So it will be 1 into y by 1. So it will become y. Now, since f of x is equal to y, if function f is onto, right? So to prove it's an onto function, f of x should be equal to y, and to prove that it's 1 to 1, x1 should be equal to x2. You should also check if whatever result you get here 1 by y, if it belongs to the set. The set given here is real numbers. Does 1 by y belong to real numbers? Yes, because you have fractions in real numbers. Therefore, this belongs to R. So now we have solved the first part of the question. Let's look at the second part of the question. If the domain R is replaced by N, which is domain here? Domain is this one, right? The first set is R star. This one, this first set. If this set is replaced by N is natural numbers, right? N is natural numbers. What is natural numbers? Numbers starting from 1 till infinity, all positive numbers only. Natural numbers will only have positive numbers and it will not have 0, right? It will not have 0, it starts from 1. So if this entire set is replaced with natural numbers and the codomain is the second set, this one, this is codomain, right? The codomain is same as R star. That means it's still real number, right? Codomain, the set will be set of real numbers and this set will be set of natural numbers. Now we'll have to check
if this will be 1, 1 and on 2 if you replace this set with natural numbers. Now this is how the function will look like, right? Function is equal to 1 by x between natural numbers and real numbers. You will have to check if this is 1, 1 and on 2. Now we'll start with 1, 1. We'll use the same thing. How will we start? F of x1 is equal to f of x2. So f of x1, what is f of x? 1 by x. So it will be 1 by x1 and this will be 1 by x2, which implies if I take reciprocal on both the sides, this will imply that x1 is equal to x2. If I take example, if I take x as 1, then what will be f of x? It will be 1 by x. What is 1 by x? 1 by 1. 1 by 1 is 1. If I take x is equal to 2, f of x will be 1 by 2, which is 0.5. So 1 belongs to r star, right? Now from here, I'm taking 1, so I'll map it to this particular element. Now if I take x is equal to 2, f of x is going to be 0.5. So if I take x as 2, f of x is going to be 0.5. So I map it to 0.5. If I take x is equal to 3, f of x will be 1 by 3, which is 0.33. So this is a set of real numbers, right? It can have infinite number of decimal numbers, infinite number of negative numbers, positive numbers. So if you take x as 3, then you can map it to 0.33, right? So in each of these cases, every element here will have distinct element in this particular set of real numbers. Therefore, you can say x1 is equal to x2. For every element that you take in natural numbers, any number you take in this set, it will have a image in this particular set. So therefore, either you use an example or use this particular method, you can prove that it is 1, 1, 1 to 1, because here x1 is equal to x2. Therefore, function is 1 to 1. Now let's look at onto. Let's go back to this example, right? Now if you look at this example, for onto, all the elements in the codomain or all the elements in this particular set should be mapped to some element in this set. Now if you look at negative numbers, for any of these particular elements, right, if I put this function which is 1 by x, will I get a negative number? Whether I put x is equal to 1 or 2 or 3 or till infinity, whatever I put, when I do f of x, that is when I put 1 by x, will I get negative number? No, because all the numbers in this set are positive numbers. So if I take this positive number and apply the function, that is I apply this 1 by x, right, I will never get a negative number, right? What I have, the x value that I have is positive here. This x value belongs to this particular set of natural numbers and x is always going to be positive. So there is no way that you're going to get a negative number. That means the negative elements here will never get mapped, right? None of these elements belonging to natural numbers will be mapped to these negative numbers. Therefore, you can say this is not onto, right? You can say since negative numbers in y does not have pre-image in n, so you can call these as pre-images and these as images, right? So for every element in R star, you don't have a pre-image. That is, these elements don't get mapped to any element in this set. So since negative numbers in y does not have pre-image in n, this is not y, you can call it as R star. Since negative numbers in R star does not have pre-image in n, the function from natural numbers to real numbers is not onto. Example, -2, -3 have no pre-images. Now we'll go to second problem. You have to check the injectivity and surjectivity of the following functions. Injectivity is 1 to 1. Surjectivity is onto. First one is the function is defined from natural numbers to natural numbers. So both the sets are natural numbers and the function is given as f of x is equal to x square. So we'll have to check if it is 1, 1. So for 1, 1, what do? We start from f of x1 is equal to f of x2. So what is the function? It's x square.
but we have x1 here, so we'll take x1 square. Here what is f of x2? It is x2 square, right? So instead of x, I'm putting x1 here, and instead of x, I'm putting x2 here. So x1 square is equal to x2 square. What does this imply? So if I take square root on both sides, if I take square roots on both sides, the square and square root will get cancelled, and I'll be left with x1 is equal to x2, but it could be plus or minus, right? For example, square root of 4 can be plus 2, it can be minus 2, right? 2 square is also 4, minus 2 the whole square is also 4, right? 3 square is 9, and minus 3 the whole square is equal to 9, right? So whenever you have square or square root, it could be plus or minus, right? It could be plus x1 or minus x1. Here it could be plus x2 or minus x2. Now what's happening? One thing to notice here is both are natural number, right? In natural numbers, you will never get negative numbers, right? Natural numbers are always positive. Natural numbers are always positive numbers. Therefore, you will never get negative x1 or negative x2. So it will be positive x1 and positive x2. Now since x1 is equal to x2, we call function n to n is 1 to 1. Now we'll prove surjectivity. Surjectivity or onto function, right? How do you prove it's onto? You'll have to start with f of x. What is f of x? X square. So we'll say let y is equal to f of x, and instead of f of x we have x square. So y is equal to x square. So if y is x square, then what is x, right? X will be square root of y, right? If x square is equal to y, then x is square root of y, correct? Now square root of y, does this belong to natural numbers? What is square root of 2? It's 1.414, right? Does 1.414 belong to natural numbers? No. Why? Natural numbers will only have whole numbers, like integers, basically 1, 2, 3, 4, 5. It will not have decimals. Natural numbers will not have decimals. So this number does not belong to natural numbers. Therefore, this does not belong to natural numbers. So basically, you can say x is equal to root y, and it does not belong to natural numbers. Therefore, function is not surjective, or it is not onto, right? If you have to use an example, you can say example square root of 2 is equal to 1.14, and this does not belong to natural numbers. Now we look at another example. This is a function from z to z. What is z? Z is a set of integers. What is z? Z is set of integers. Now it could be positive or negative, but it will be integers. Basically, it will not have decimal numbers. It will only have whole numbers like 1, 2, 3, 4, plus 1, minus 1, plus 2, minus 2. This entire series is set of integers. Now the first set is also an integer. Second set is also an integer. So basically both these sets are integers. Now you'll have to prove that this function f of x is equal to x square is injective or surjective. You'll have to check, right? So we'll take the one-on-one case, one-to-one case. First let's check if it's injective or one-to-one. Now there are two methods to do this. You can first start with f of x1 is equal to f of x2. Or you can take an example also and explain. Using an example, it is simple because this has both positive and negative numbers. Now when I take square, so for example, if I take x is equal to plus 1, f of x would be 1 square, which is 1. If I take x is equal to minus 1, f of x would be minus 1 the whole square will be 1. Now you notice both plus 1 and minus 1 has the same image, which is 1. That is, here you notice
plus 1 and minus 1 both are mapped to plus 1 here. So this becomes a many to one, not one to one, because two elements in this particular set are mapped to one element in this particular set. So this is many to one, that is both are having the same image, which is plus 1 here. So therefore this is not one to one. So you can say function from z to z is not one to one because plus 1 and minus 1 have same image. Therefore this function is not one to one. Now we can use other method also. F of x1 is equal to f of x2. What is f of x1? It will be x1 square. What is f of x2? x2 square. If I take square root on both sides, I'll get x1 square is equal to root of x2 square. Root and square will get cancelled. So I'll be left with x1 is equal to x2. Notice it's going to be plus or minus, right? Every time you have a square root or a square, it could be plus or minus. So I can write this as plus x1 could be mapped to x2, minus x1 also could be mapped to x2. Now if you notice this, plus x1 and minus x1 both are mapped to same images, right? Therefore you can say function is not injective or one to one because x1 and minus x1 is having same image x2. Now we'll check if it is surjective or onto. We'll use an example here. Both are integers, right? Every element in this particular set should be mapped to some element in this particular set. Now if I look at minus 1 or minus 2, I look at any negative numbers, I will never get a mapping in set x. Is there a way that minus 1, minus 2, minus 3 will be mapped to some element in this particular set? There is no way, because you take plus 1 or minus 1, it will become 1, right? If I take x is equal to 1, f of x is going to become 1 square, which is 1. If I take x is equal to minus 1, f of x is going to become minus 1 square, which is 1. So there is no way, no matter whatever I do, I will never get minus 1 as the image, right? It will always be plus 1, plus 2, plus 4. It will always be positive numbers. I will never get negative numbers because they can never become images of any element in this set. So I can say function from z to z is not onto because minus 1 is not an image of any element in z. Or I could also say it's not onto because minus 1 is not having any pre-image, right? Pre-images, the elements here you can call it as pre-images. So minus 1 from this particular set doesn't have any pre-image. Now the other method is, you can use another method also. You can use this method. You say f of x is equal to x square. Let y be x square, right? It is basically y is equal to f of x. So what is f of x? X square. Then therefore what is x? X will be root of y. Root of y, it cannot belong to integer, right? Same example. If I say root of 2 is 1.414 and this does not belong to integer. So since root of y does not belong to integer, you can say function from z to z is not onto. Now let's look at a third example. You have to check if function from r to r, same function, x square, right? But here the sets are different. Both are real numbers. And what are real numbers? It's a set of all numbers, right? Minus 1, minus 2, plus 1, plus 2, fractions, decimals. Now you'll have to see if the function from r to r is 1, 1 and onto. Now let's check 1, 1. Now same thing. F of x1 is equal to f of x2. So x1 square is equal to x2 square, which means plus or minus x1 is equal to plus or minus x2. Which means plus x1 is equal to x2 or minus x1 is equal to x2, right? Both plus x1 and minus x1 are mapped to same element x2. Therefore, it is not 1, 1. So using example also I can say -1 and +1 both are mapped to +1 here. So therefore it is many to one. It's not 1 to 1. So you can say -1 and +1 has the same image. Therefore the function is not 1, 1. Now we'll check if it is onto. Again, it will not be onto because for negative numbers, since it's a square function, right? X square. Anytime you have a square function, you will never get an pre-image for negative numbers. That is, these negative numbers can never be mapped to any element in this particular set, right? So example -2 -1 has no pre-image. Therefore, it's not onto. And you can also use this particular method, right? You start with f of x is equal to x square and assume that y is x square. Therefore, x becomes root of y. And root, if you have a negative number here, right? If you have a negative number, then it will not belong to real numbers because you can never get a root of negative number. Can I get a square root of negative number? It's not possible. It's not there in this particular real number set, right? Square root of negative number is not valid in this particular set. So you say this does not belong to R. So basically y is negative. Y can be any value, right? Because you can take any positive number or negative number. If you take a negative number, then the result does not belong to R. Therefore, function from R to R is not onto. Or you can use this particular example. Since -2 -1 has no pre-image, function is not onto. Let's take fourth example. Function from n to n. Here it's a cubic function. Cubic function. So you'll have to check if it's 1, 1 and onto for a cubic function. Now you will take the same method, right? x1 cube is equal to x2 cube, which means x1 is equal to x2. Here you will not get plus or minus. Here you will never get plus or minus here because it will only be one of them, right? So if I take -2 the whole cube, I will get -2 into -2 into -2, which is -8. If I take +2 the whole cube, it will be 2 into 2 into 2, which is +8. So whether I take positive number or negative number, the image is going to be different, right? If I take -2, I'll get -8. If I take +2, I'll get +8. Since the images are different, right, it is distinct. So it's not like square function, right? In square function, whether you take -2 or +2, your answer is going to be same, right? But in cubic function, that's not the case. So therefore, you take any element in this particular set. 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64. So you see all the elements are distinct. Now, one more thing to notice here is, it's a natural number. You don't have negative numbers at all, right? You don't have negative numbers at all. So it's all positive numbers here. So even if I take any positive number, I'll have distinct, right? There is no way that I will get same image for two numbers here. It will always be different. Therefore, this is 1 to 1. Using this method also, I can say it's 1 to 1. Using an example also, I can say it's 1 to 1. So I can say every element in set X has distinct image in set Y. Hence, F is 1, 1, right? If I take this as set X and set Y. Now let's see if it is onto. For onto, using an example, you take any number from 1 to infinity, right? 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube will be 64, 5 cube will be 125. If you notice, for numbers between 1 to 8, that is 2, 3, 4, 5, 6, 7, it can never be mapped to any element in this set. So all these elements between 1 and 8, 2, 3, 4, 5, 6, 7 can never become an image of any element in natural numbers. These have no pre-images. So 2, 3 has no pre-images. Therefore, F is not onto. This is using example. Now using this particular method, f of x is equal to x cube. Assume that y is equal to x cube. So x will become cube root of y, right? Y is equal to x cube means x is equal to cube root of y. Now, if I take cube root of y, let's assume cube root of 3. Let's take y as 3 because 3 is a natural number, right? 3 is a natural number and this 3 belongs to this particular set. If I take cube root of 3, I will get a decimal number, right? I will always get a decimal number. And decimal numbers don't belong to this set of natural numbers. So cube root of y could be decimal number, and decimal number does not belong to natural number. Therefore, function from n to n is not onto. Now let's take this fifth example. Function from z to z. Same cubic function, but this time it is from integer to integer. Now z means it could be both positive and negative integers, right? Both are z. Now let's check if it's 1, 1. Case of integers, you'll have both positive and negative. Like I said, minus 1 the cube, the whole cube is minus 1. Plus 1 the whole cube is plus 1. So images are distinct. Minus 2 cube is minus 8. Plus 2 cube is plus 8. So there are distinct images. For every element in this particular set, there are distinct images here in this set. Therefore, this function from z to z is 1 to 1. Right? You can use this method also. x1 cube implies that x1 is equal to x2. Right? And therefore, this function is 1 to 1 or injective. Right? Or you can use an example and say every element in set x has distinct image in set y. Therefore, this function is injective. Now let's look at onto or surjectivity. Right? So we'll assume f of x is equal to x cube. We'll assume y is equal to f of x. That means y is equal to x cube, which means x is equal to cube root of y. X is equal to cube root of y. Now in this set y, this is y, right? This represents y, this represents x. So y can take both positive and negative number. Now if I take negative number, right? If I take minus 3, cube root of minus 3, right? Cube root of minus 3 does not belong to integer. Does not belong to integer. Because cube root of minus 3 does not exist in integers. It's going to be some imaginary number, right? Cube root of minus 3 is an imaginary number. It does not belong to integer, or it does not belong to even real number. Therefore, you say this function is not onto. You can also say minus 2, minus 3, these numbers don't have any pre-image, right? Because if I take x is equal to 1, then f of x is equal to 1. If I take x is equal to 2, then f of x is equal to 8. Now between 1 and 8, there are so many numbers, minus 1, minus 2, plus 3. None of these numbers will have any pre-image here.
With this, we've come to the end of this particular video. We will solve few more problems in the next video. If you found this video useful, do press a like and share it. Thank you.